ओके, गुड इवनिंग स्टूडेंट्स। तो आज हम एक स्पेशल वीडियो रिकॉर्ड कर रहे हैं आप सभी के लिए। ओके, सो दिस वीडियो इज डेडिकेटेड टू दोज स्टूडेंट्स हु आर नॉट प्रिपेयर्ड फॉर बोर्ड एग्जाम्स 2025। ओके, कि अगर हम देखें तो हमारी क्लास में या हमारे आसपास कुछ ऐसे बच्चे हैं जो थोड़ा सा वीक हैं, ओके, पढ़ाई में कमज़ोर है, उनको जो है फिजिक्स में बहुत ज़्यादा प्रॉब्लम आ रही है। सो दे कैन प्रिपेयर दीज 18 टॉपिक्स। ओके, सो वी हैव ऑलरेडी डिस्कस्ड अबाउट दीज 18 टॉपिक्स while we are discussing about physics in our classes. Okay, so these topics are, as mentioned above, important topics for board exams 2025. So the first topic is electric dipole. Okay, this is very important topic. Electric dipole, you can prepare the definition of electric dipole, and you can prepare dipole moment, the definition and the expression for dipole moment, and the expression for torque and energy stored. Okay, so we have dipole moment, already knows about it, a system of two equal and opposite charges, and the dipole moment denoted by small p, q into 2l, having its SI unit coulomb meter. Torque, we have the expression for torque P cross R. Okay, and the energy stored W equal to P cos theta 1 minus cos theta 2. So we can prepare these expressions and some definitions from this topic. Okay, you may have any one question in your board exams from this topic. It may be numerical, and the expressions for dipole moment, torque and energy stored in the dipole when it is placed in uniform electric field. Okay, so next we have electric field due to infinite plane sheet. So this expression comes from the application of Gauss theorem. Okay, so you do not need to remember Gauss theorem, but you can prepare this expression. This is the application of Gauss theorem, and the diagram is very crucial. So आप इसका डायग्राम बनाते समय थोड़ा सा केयरफुल रहेंगे जब भी आप इस एक्सप्रेशन को जो है प्रिपेयर करेंगे। और सिंपली इसमें क्या होता है, इलेक्ट्रिक फ्लक्स डेफिनेशन एंड गॉस थ्योरम का कॉम्बिनेशन यूज होता है इसके अंदर, and you can easily find out the electric field due to a plane sheet, infinite plane sheet of charge. Okay, and the expression comes equal to sigma upon 2 epsilon, where sigma is surface charge density and epsilon naught is permittivity of free space. Okay, so this topic frequently comes in your board exams. Last time हमारे पास क्या आया था, spherical cell. Now we have the chances of this topic in your current board exams. Next is electric flux. Very simple definition. It is given by or number of electric field lines passing through any surface area normally, denoted by phi, and it is given by E into A. SI unit is Newton meter square coulomb inverse. So it has very simple definition. You can prepare electric flux, definition of electric flux. Next we have equipotential surfaces. We have some other important topics including these topics, but we are making this video only for the weak students. That's why we have some important topics in this video. We are including these important topics in this video. Next is equipotential surfaces. So as we already know about equipotential surfaces, already discussed about equipotential surfaces in our classes. Okay, so what are equipotential surfaces? The surfaces which have same potential on every point on it. Okay, So if this is the equipotential surfaces and these are the 2 points which are having potential VA and VB. So in this, in the case of equipotential surfaces, VA will be equal to VB. Okay. So very simple definition. You can draw various equipotential surfaces like due to isolated charges, pair of charges, like and unlike, and due to of uniform electric field. Okay. So and you must study about properties of equipotential surfaces like the work done on equipotential surfaces always zero. Okay. And next is electric field is always perpendicular to the equipotential surfaces, never intersect each other. And the last one is comes closer in the strong electric field and moves apart in weaker electric field or weak electric field. So very simple topic, you can prepare it. Next is expression for drift velocity. So expression, this expression is very simple and very important. You may have this expression in your board exams. Okay. So the expression for drift velocity in terms of electric field, Vd equal to minus E upon m into tau. And this is the expression of drift velocity in terms of electric field. You may have the expression for drift velocity in terms of applied potential difference across the ends of the conductor. So we know about it, E equal to V upon L for uniform electric field. Mn. Okay. So you can prepare this expression. Also we have one topic related to drift velocity, the relation between current and the drift velocity, NEAV. You can prepare this expression also. This is also very simple. So prepare the definition. Okay, very simple definition. The average velocity which is gained by the electrons when they are drifted towards to the positive end of the conductor. Okay, you can apply two conditions without applying potential difference and applying potential difference, and you can use first equation of motion, and by using the first equation of motion you can easily find out the expression for drift velocity. Okay, here negative sign tells about the direction of the velocity of the electron. Okay, galvanometer. So prepare for galvanometer, its construction, working, theory, everything, its conversion, conversion into conversion into ammeter. So we have conversion into ammeter and conversion into voltmeter. Okay. You can easily convert it into ammeter. So to convert into ammeter, we need to require applying shunt resistance when we want to convert galvanometer into ammeter. So this is the galvanometer. It has high deflection current Ig, or we want to make an ammeter of current I. So we need to pass on this excess of current through the shunt. As current through the shunt, that will be I minus Ig. By using Kirchhoff rule, you can find out the required shunt resistance or shunt resistance to connect with the galvanometer into parallel to convert it into an ammeter. As similarly, to convert galvanometer into voltmeter, we need require high value resistance in series. This is the series resistance, high deflection current. Okay, and the V is the potential drop across this combination. So we can easily convert galvanometer into voltmeter. It is basically used to detect small current. We can increase the sensitivity. So you may have some knowledge about how can we increase the sensitivity of a galvanometer. Okay. Next is type of materials: di, para, and ferro. So you will have one question from this topic: diamagnetic, paramagnetic, and ferro. So these both have the same property like, and di is having opposite property. So prepare about these three materials. Next is Faraday laws. So we have two laws. EMF produces till the change remains, and next is induced EMF E equal to minus N d phi over d. Negative sign, the direction of induced EMF, and that will be opposite. Okay, so this negative sign shows that the direction of the induced EMF. Next, mutual induction. You can prepare a definition. You can take two mutually coupled solenoids, and you can write the expression for the two mutually coupled solenoids. You may have numerical in the exam, or if you don't know about the numerical, you can simply write the formula of mutual induction for two mutually coupled solenoids. Next, we have RMS value of AC. So do not require the expression for RMS value and average value. You simply need to remember the RMS value of AC, 0.707. So already know about it. IRMS 0.707 of I, peak value, and similarly VRMS equal to 0.707 of V, peak value. Next, we have transformer and its losses. So already know about it. What is the use of transformer? So it is used to step up or step down AC voltage, and the principle of working of a transformer, obviously mutual induction, and its losses. So we have many types of losses like eddy current loss, copper loss, flux loss, homing loss, and the methods of reduction of these losses. So prepare very important topic, transformer. Okay. Next we have EM wave diagram. So prepare the diagram of EM wave and its speed, formula for its speed. Okay. Basically, you need to prepare the diagram of EM wave. Okay, prepare it. And next we have electromagnetic spectrum and its component. So you need to remember the name of its component, their ranges like wavelength, frequency, and how can we produce these components, the methods of production, who discovered, and the uses of these components. Next we have microscope and telescope. So diagrams are very important, and the expression for magnifying. You do not require to write the derivation for the magnifying power. You have only need to remember the diagram and the expression for magnifying power. So already know about it. What is microscope, or we can say that compound microscope. So microscope or compound microscope and telescope. Compound is the simple magnifying glass, microscope is the simple magnifying glass, and compound microscope is the combination of objective and eyepiece. It is used to observe very tiny objects and the magnified image of very tiny objects, and telescope to observe long distance magnified image of long distance objects, like we have terrestrial objects or some astronomical objects. So their types, a refracting type and reflecting type, like Cassegrain telescope. So prepare the diagrams and their magnifying powers. Next is TIR, total internal reflection. So what is total internal reflection? Critical angle and applications of TIR in our daily life. So like we have mirage and optical fiber, okay, in endoscopy. So basically you need to prepare optical fiber, and what is the construction of optical fiber and its working of and its working. Next we have minimum deviation through a prism. So now we need to prepare the condition of minimum deviation. Minimum deviation condition आप सभी जानते होंगे इसके बारे में. So what is the condition of minimum deviation? When delta equal to delta m, in this case what happens? I equal to E and R1 equal to R2 equal to R. Then we have R equal to A upon 2. And I equal to you can apply the I equal to in the equation of deviation through in the equation of refraction through a prism. Okay, so you can use this term in the equation of refraction through a prism, and you can also prepare this formula for minimum deviation, sin A plus delta m upon 2 upon sin A upon 2. Next we have Young's double slit experiment. So Young's double slit means interference and diffraction. So there is no need to prepare the derivation for fringe width. You need to remember the theoretical knowledge of the Young's double slit experiment, and similarly like for diffraction. So no derivation, only pattern and the difference between the interference and the diffraction, and how the fringe width in case of interference and diffraction depends on the parameters of the slits, like the slit gap and the slit width. Next we have threshold frequency. Already knows about it. Threshold frequency, the minimum frequency below which the photoelectric effect is not possible, and we need to know the laws. So prepare the laws of photoelectric effect. Obviously threshold frequency, intensity and the frequency. So prepare these laws, and you can also prepare graphical treatment. Graphical treatment. So prepare graphical treatment to find out the work function and the Planck constant. Next, Rutherford's experiment, observation and conclusion. And you can also prepare Rutherford's atomic model, achievements of Rutherford's, and the demerits or limitations of Rutherford's atomic model. Next we have Bohr's model. So you can Bohr's model. In Bohr's model, you can prepare a total energy of an electron in the orbit revolving around the nucleus, and the spectral series of hydrogen atom. So from this topic, you may have numericals like transition from one orbit to another. You have to find out the frequency of the emitted photon. Next we have mass defect. So prepare the definition of mass defect. You can also prepare mega electron volt. What is mega electron volt? And mass defect and binding energy. Okay. Next, you can also prepare nuclear reaction. Nuclear reactions. So prepare this topic also. I think last year इसमें nuclear reaction, nuclear fusion का क्वेश्चन था. इसमें mass defect, binding energy, nuclear reaction, and you can also prepare binding energy per nucleon, atomic mass number graph. Okay, or you can also prepare potential energy of nucleon inside of the nucleus. Next we have PN junction, diode and rectifiers. PN junction, अब PN junction में क्या रहेगा आपका, what is doping, intrinsic charge carrier density. Okay, in case of intrinsic semiconductor we have Ni equal to Ne, in okay, N equal to means we have intrinsic charge carrier density Ni. Okay, in that case Ni equal to Ne into Nh. Okay, and in the case of highly doped semiconductors this equation changes. Okay, so एक बार इसको देख लेंगे और इसमें क्या रहेगा आपका पीएन जंक्शन, फॉर्मेशन ऑफ पीएन जंक्शन, मेजॉरिटी एंड माइनॉरिटी चार्ज कैरियर्स, कैरेक्टरिस्टिक ऑफ पीएन जंक्शन and rectifiers. Two types of rectifiers. Two types of rectifiers. We have full wave rectifier and then we have half wave rectifier. Okay. Okay. So rectifiers. We have two types of rectifiers. Half wave rectifier using single diode, and we have full wave rectifier using double diode and center tape transformer. Also you can use make full wave rectifier using 4 diodes. Okay, so in waveform input frequency in case of half wave that will remain same, and in case of full wave that becomes डबल ऑफ द इनपुट फ्रीक्वेंसी. आउटपुट फ्रीक्वेंसी फुल वेव के केस में क्या हो जाएगी, डबल हो जाएगी. आपको ध्यान रखना है. सो एक इक्वेशन मैंने यहाँ पे लिखी थी. सो इन केस ऑफ इंट्रिंसिक सेमीकंडक्टर वी हैव इंट्रिंसिक चार्ज कैरियर डेंसिटी Ni स्क्वायर इक्वल टू Ne into Nh. इन केस ऑफ p टाइप सेमीकंडक्टर वी हैव Nh is greater than Ne. in case of n type semiconductor Ne is greater than N. तो यही सब कुछ मेन चीजें हैं यहाँ पर. इनको पढ़ लेना. वैसे तो पढ़ने के लिए बहुत कुछ है इसमें, क्योंकि हर टॉपिक से आपको एक ना क्वेश्चन आपको आपके क्वेश्चन पेपर में देखने को मिला है. कुछ न्यूमेरिकल्स वगैरह पे लेंगे, क्योंकि कुछ चीजें हमने यहाँ पे छोड़ दी हैं. फर्स्ट चैप्टर से बहुत कुछ छोड़ा है अभी इसमें. तो लेकिन ये जो टॉपिक्स मैंने यहाँ पे लिए हैं इनसे मोस्टली क्वेश्चन आते हैं. तो सभी स्टूडेंट्स क्या करेंगे, कोशिश करेंगे कि ये वाले क्वेश्चंस आपको पढ़ने हैं. ठीक है, आपको कुछ ना कुछ इन क्वेश्चन से आपको मिलेगा. अब इसमें जैसे रहता है आपका लेंस मेकर फार्मूला, तो उससे न्यूमेरिकल्स भी आने के चांसेस रहते हैं. या फिर आपका रिफ्रैक्शन थ्रू स्फेरिकल रिफ्लेक्टिंग सरफेसेस, उससे भी न्यूमेरिकल आने के चांसेस रहते हैं. और इसमें माइक्रोस्कोप और टेलीस्कोप से भी आपके लेंथ वाला जो फार्मूला है उसका यूज़ करके भी आपके न्यूमेरिकल आने के चांसेस रहते हैं. तो ऐसे तो बहुत कुछ है, लेकिन जो हमारे पास इम्पोर्टेंट है, जो हमें पासिंग मार्क्स के लिए चाहिए, वो चीज़ें मैंने यहाँ पे इंक्लूड की है. तो आई होप कि आपको इस वीडियो से कुछ ना कुछ हेल्प मिलेगी. सो बेस्ट ऑफ लक फॉर योर एग्जाम्स. ओके, थैंक यू.